We're continuing to look at composition of compounds. We looked at how you can use percent composition as a conversion factor. And this is even more useful in chemistry, conversion factors from chemical formulas. So in the chemical formula is a conversion factor relating to the numbers of atoms and the numbers of molecules. So if we look at this formula, which is a Freon, C2Cl4F2. This gives us the ratio of atoms, 2 atoms of carbon to 4 atoms of chlorine to 2 atoms of fluorine. It also gives us the ratio of moles. So in 1 mole of this compound, we have 2 moles of carbon atoms, 4 moles of chlorine atoms, and 2 moles of fluorine atoms. So we can make conversion factors like this. So from this formula, we get 2 moles of carbon for every 1 mole of the compound. Or we can tip that, oh, that's not tipped upside down. This is a different one. So this is chlorine. It'd be 4 moles of chlorine for every 1 mole. These numbers are coming out of the chemical formula itself. Okay. It is important to remember that these give the relationships between moles. Moles is a counting unit. Mole is a counting unit. So it's giving the relationship between numbers of particles. It's not giving the relationship between masses and grams. It's numbers of particles. So let's do an example where we use that. So here's a question. Determine the mass of oxygen in a 7.2 gram sample of aluminum sulfate. Well, there's only one number given here. Many of these problems end up being dimensional analysis problems. So we have 7.2 grams of aluminum sulfate. We're going to need the formula for aluminum sulfate, so we'll practice our nomenclature. What's the formula for the aluminum ion? Al3+. We should recognize this as an ionic compound because aluminum is a metal. Anything with a metal in it in this class is ionic. And then we need sulfate. SO4 2-. How do we know that? We memorize it. Okay, so when we put these two together, you could do the crisscross thing, or you can just reason it out. The formula is going to be Al2 SO4 3. And just a reminder, when we have more than one of a polyatomic ion like sulfate, we put parentheses around it and we put the number of those ions on the outside. So we have 7.2 grams of this formula, Al2 SO4 3. What are we asked to find? Mass of oxygen. Okay, so over here, I'm trying to get to grams of oxygen. We're talking about oxygen in a compound, so we're not talking about O2, we're talking about just O. O2 applies when it's all by itself. It's not by itself here. It's with sulfur and aluminum. So we have to figure out how to get from grams of the compound to grams of the element. What often goes in the middle? Moles. Molar mass, moles in the middle. So if you're not sure how to bridge the gap, try moles in the middle. So using a molar mass, we can go from grams of this compound to moles of the compound. Right? So we can go to moles of the compound. And what we just looked at is that by looking at this chemical formula, we have a relationship between moles of compound and moles of oxygen that is within the formula itself. So we can convert to moles of oxygen, and then using the molar mass of oxygen, we can convert to grams of oxygen. Any questions? In problems like this, where you're talking about an amount of one substance and an amount of another substance, it becomes very important to specify grams of what, moles of what. Otherwise, things go wrong. There's a bunch of chairs up here. So finding the path, that's the hard part. Once you get that, is just following a pattern. So 7.2 grams of aluminum sulfate. My path has 3 arrows, so I'm going to have 3 fractions. The units in the path are the units that go on the numerator of each fraction. So grams of aluminum sulfate to moles of aluminum sulfate. I know it gets tedious to write the formula over and over again. To moles of oxygen, to grams of oxygen. Previous unit goes in the denominator. So we get those in there. And we make sure moles of oxygen cancel, moles of aluminum sulfate cancel, grams of aluminum sulfate cancel. All the units in first. I can tell by grading your exams that some of you are not using dimensional analysis yet. Some of you are good at getting the correct answer with things like inches and feet and gallons and pounds and stuff. But it becomes more difficult to reason out whether you should multiply or divide when you're using grams and moles of substances. So from long experience, I can tell you that if you learn how to write it out like this, you will be more successful in this class. So please just give it a try. The units tell me where to put the numbers. I tend to look at this and fill in the easy ones first, because why not? So this one looks easy to me. Moles of oxygen to moles of aluminum sulfate. That comes from the formula. In one of these units, I have 4 times 3, I have 12 oxygens in that unit. So I have 12 moles of oxygen to 1 mole of aluminum sulfate. It's like looking at a wagon. You have 1 wagon, how many wheels? 4 wheels. So sulfate is a little bit like a wagon with 1 wagon body and 4 wheels. If you have 3 wagons, how many wheels do you have? 12. Okay, it's the same concept. People just kind of lose their minds when we put letters up here. What's this number? Grams of oxygen to moles of oxygen. 15.9994, or I just use 16.00. That's straight off the periodic table. Now this one. How do we get this one? We got to add some stuff up. We got to do some math. So we look at the chemical formula. We've got 2 moles of aluminum. So I need 2 times the mass of aluminum. And I've got 3 sulfurs. So 3 times the mass of sulfur. And I already figured out I've got 12 oxygens, and those are 16 grams each mole. So 2 times 26.98 plus 3 times 32.07 plus 12 times 16. And again, if I screw up, please tell me right away. So that's grams are equal to 1 mole of that compound. Or we can put the units as grams over moles. The molar mass is the mass of 1 mole of that substance. So in this term then, I have moles on top and grams on the bottom. The number I just calculated goes in the denominator. And we can see that I didn't leave enough space, but we can work around that. Got all the numbers in place now, my units cancel out. Entering this into my calculator, you want to start at the left, multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Just go straight across. It's much better, it's more efficient, there's fewer mistakes than trying to multiply all the tops, write it down, multiply the bottoms, write it down, and then divide. It takes longer, and every time you write something down and put it back in your calculator, you could make a mistake. If it bothers you that there isn't a number up there, you can put 1. So I've got 7.2 divided by 342.17 times 12 times 16. And I end up, my starting number had 2 significant figures. Everything else has more. This 12 is exact. Just like on a wagon, there are exactly 4 wheels. You can't have 3.5 wheels, right? It's whole numbers of wheels. These numbers coming from the formula are exact. So my answer should have 2 significant figures. So I'm going to write, as I write this down, I'm thinking about that. There's the second sig fig. I write down 2 extra digits, and then I'm going to round it, and this is 4.0 grams of oxygen. Always ask yourself, is that answer reasonable? Well, how can we tell? Well, we've got 7.2 grams of the compound. The mass of oxygen must be less than the mass of the whole compound, right? So that doesn't prove that this is correct, but it's encouraging. If we ended up with 14 grams, that would be unreasonable and prompt us to examine our work. Any questions?